Hello everyone, this is Ari from pantechelearning. So previous session we have developed some codes and we have shown some outputs, right? So today we are getting into a new concept which is system tick. So today we will see what is system tick and why we are using system tick, and we will create a delay function using the system tick function. Okay. So we will get into the class. So what is a system tick generally? So it will generate an interrupt at the fixed time interval. So what is going to do is it is going to generate some interrupt. Okay. So it is going to generate an interrupt at a specified time interval. So I will show the what is the specified time interval. Okay, will be. So what are the things we can do with this is we can use it for measuring our delay time. So we can create a delay function using this system tick function. Then we can use executing the task periodically, such as periodic polling and OS. And also you can see this system tick will be used maximum in the developing the RTOS, real-time OS. So every time system will do some operations when this system tick interrupt is generated. Okay. So the system tick is like a system timer is a standard hardware component built in the ARM Cortex M family. Okay. So all the Cortex M will have an inbuilt hardware component which is a system timer. Okay. So this hardware is periodically force the processor to execute the following ISR. What is ISR? Interrupt service routine. So what is this is? We have a hardware component that is a system timer which will be available in our controller. Okay. So this timer will always generate an interrupt at the specified value we are given. Okay. At the specified time. So it is going to generate some interrupt, right? So by handling it is going to do some ISR routine. So what is ISR routine means? When the interrupt is generated, it is going to do some operations. So I'm enable the interrupt for the system tick means. So it is going to generate an interrupt every time at a specified frequency or a time. So then I will write a function in a void of system tick handler. We will have it in a default in the startup file. So I will use this handler. I will give some functions, do some functions inside this. I'll write some functions to do microcontroller to do. I'll write those codes in this inside this interrupt handler. So what it will do is when this interrupt is raised, then it will get into the interrupt handler and do executes the code which is inside this handler. So this is the help of this system timer. So we can use this system timer without configuring this is a system timer without using the timer peripherals. So we can directly use this system timer without the help of the timers. Okay, it is a specific different separated part. Okay, so by using this we can do some operation at the periodically at the same interval of time repeatedly. So this is what system timer is. So why we are going to it. So this system timer will be connected to the NVIC, which is a interrupt controller. So every interrupts will be controlled with this, and it will only gives the interrupts to the peripheral and input output. Okay. So this will be the processor, and the system timer will work at the it is going to be work in the system frequency. So if my system frequency is 16 megahertz means it is going to work in the 16 megahertz of frequency, or we can use the HB bus by using the HB bus prescaler we can use the H clock also. Okay. So what is H clock means? Wait, I will show you. So you can see it, right? So we can use this system clock frequency, or we can use this prescaler, and we can also use this H clock. So we can use any of these clocks by giving the setting logic 1 or 0 in the control range. So we will see it in coming slides. Okay. So next is our counter. So this is what going to count the time. Okay. So what is the system timer is going to do is it is going to give an interrupt at a specified interval of time. So this is this counter is 24-bit. It is 24-bit down counter. So you can see here it is going to count from what is the value we have given to the value of 0. Okay, it is a down counter. So down counter means it is going to count in the downwards. Up counter means it is going to count from 0 down counter means it is going to count from the value you are specified. So it is going to count from 10 to 0 down. It is what is down counters. Okay. So here the value will be, we will roll the, what is the value to start this, we will load it in the load register, reload register. So we will say it, I have set this reload value as an 100, okay, for a example. Okay, so this will send the value to the counter. So from 100 it will reduce the counts to the 0. When it reaches the 0th count, so it is going to, if it is 0, it is going to give an interrupt and it is going to give the message to the reload value. Then again it is going to copy the reload value from, starts from 100. So this is how the counter is working. So it will start from 100 and it will count till 0. When 0 attains, it will give an interrupt and a flag, and it will again gives the information to the reload register to send the value from the new start. So it again starts from the 100 to 0. So this is what the counter out works. Okay, it is it. So you can see this is the timer. This is how the counter works. So I consider I have given the load value as 6. So it is going to start the count from the 6 and it is going to come to the 0. When it comes to the 0, it is going to give a systematic interrupt. So as I said, you can see it will give an interrupt. So by enabling the NVIC interrupt enabled. So if we do that means we can give some function inside this interrupt handler. So when this interrupt is generated, it will get into the interrupt handler and do some operations just inside the interrupt. The code we have written inside the interrupt. So this will go to the 0, then the interrupt is generated and the flag also given set as a logic 1. Then it again starts from the load value which is we have given. Then again go to 0. This is the process. So the system interrupt time period can be given by system tick load plus 1 into clock period, or you can for instead of clock period you can do the clock frequency, which is in our scenario it is 16 megahertz. So we can give the load time plus 1 into clock frequency. It will give us the what is the time system tick interrupt time period. Okay, this will give the time period between these. Okay, so next is, this is how the system tick will be interface. So this will take the clock from the AHB clock. It can be a processor clock, or it is divided from the, it can be H clock, which is come from the AHB prescalers. Okay, so it will get into the, now we have a control register. So we have to, this is a 0th bit will enable the counter. Okay, so this will, when we are enable this counter, this will go to the counter. Before that we have to set the reload value. So I will set the reload value as 16. Okay, so my clock is 16 megahertz. So we will take a scenario. So my clock is 16 megahertz. So I have to generate a 1 microsecond. Okay, so every time from reload value to 0, it takes a time period of 1 microsecond. Okay, so this is what I am going to generate. So I will give this reload value as 16 minus 1, which is 15. Then I will enable this counter, and I will select the clock source. And what clock source I am going to use, processor clock or external clock. I will use processor clock of 16 megahertz. So I will set the logic on here, and this is the 16 bit. This is the flag. So what is this flag is going to do is, wait. So when I enable the control, when I enable the counter, so it is going to go to the, get into the counter, and it is going to start the counting from. So what is the value I have given? I am given 16. So it is going to start the counting from 16 to 0. When it attains the 0, it will gives if it is 0, then it gives an interrupt and it will set the count flag. So it is a 16th bit is the count flag. So it will set the count flag as to the 1. Then if I enable this, we can use this system clock in two ways. One is in the interrupt way and another one is polling. So in polling method, we will have we will set this tick interrupt is in the 0, so the interrupt is disabled. So we will get a count flag as a 1. So I will check with this count flag and I will do some delay or operation. Okay, so if I am using interrupt, so you will take a scenario, I am going to use interrupts. So I have set logic 1 in this first step. So what it is going to do is, when this count flag is when this counter reaches the 0, it is going to go give me a value to the, send the value to the reload value to reload the value. Then it will also set the count flag as 1. So when this count flag is set as a logic 1, it is going to go to this AND gate, and already the tick interrupt is enabled, so it is also logic 1. When this both the input is logic 1 means it is going to give a generator 1. So then the system clock will give the interrupt. Okay, so this is how the process is going on inside the system timer. Okay, system tick. So before going to the next slide, so you can now convert this masterclass into an internship, guys. So in internship, it is going to be very detailed manner, and it is going to be very much useful for you. So it will be in very much brief, and we are going to plan to add some lots of content to it. So we have lots of CAN, LIN protocols, lot of these things in the pipeline. So this fees is 1200, so you don't need to worry about this fees 1200. You can use this ESMC1 coupon code. So by using this, you can get this 509 as a discount, and you just want to pay a 691 only. So by paying this, you will get lots of benefits. What's the benefits? First is you will get this 30 days of live session recordings. So what is this use of this getting the live session recordings is? So we are we are learning new concepts, and we are implementing in the career, and we are practically seeing it the board, right, output in the board. So when you are also learning, and when you are have to upgrade yourself means you have to do some hands-on practice, and you have to do some lots of training. So while you are executing this, what are the things I have teached you means, so what are the things I have teached you, you are executing it means you will get some error or a bug, or if you stop means you can refer, you can use those 30 days recording as your reference. So you use those videos as a reference, and even the if the class is not understandable means you can see the recordings once again. So by seeing the once again, you will get the concept clearly in your idea. Okay, so this is the main benefit for it. Next is we will do lots of hands-on practice on embedded projects. So it will be very much useful. So you can use those reference video to create your own projects, and you will get a 30 days of downloadable presentations. So not alone these presentations, what are the things we are using? We are using like a reference manual, programming manual. We are using digital data sheets. Lots of things we are using. So these are the things you will get as downloadable things, downloadables, and also included the codes I am developing now right now. In class, I'm in front of you live. I am developing lots of codes, right? So those codes files also will be .c files also will be shared in the internship downloadable presentations along with the presentations. Okay. So this is another benefit. So what is the main advantages? We will have a 6 mentor lives in mastermind sessions. So what is this is we will have a one-to-one interactions. So you can interact with me directly in lives, and in lives you can't interact with me, or you can't ask a specific doubt or a specific doubt related to some of the parts. So you can't ask it. When it comes to the internship, you can ask the questions directly to me, and I will give some solutions, or I will try to give a better solution for it. So it is already the 2 classes is over. So every Saturday we will have a one-to-one live session. So this from this Monday it is going to be a third batch, starting the third batch. So guys, the link will be provided in the WhatsApp. Sorry, it is not WhatsApp. So link will be provided in the chat box, guys. So you can use those link to register for the internship. So it will be very much useful for you while practicing this all things I have teached you. When you are practicing these all things, when you have some doubts or coding related errors means you can use this live session to interact with me and clarify your doubts. Okay, and even you can get a new knowledge in about what is the specific apart from the class. If you have any doubts apart from the class means you can also ask to me in the live sessions. And so the 4 classes are left, so you can register for this. So then you after registration of internship, you will get an internship confirmation letter. And what is the main benefit is we are going to give 2 e-certificates. One is for completion, and another one is for participation. So this will be very much useful for noting it in the resume. So you can mention this certificates in the resume for entering the placements. Okay. So our fees is 1200, guys. So use the CSMC1 coupon code. So which will be you will get a discount of 509. So you have to pay the fees. The final internship fees will be only 691 only. So this is a link. So this link will be available in the chat box right now. So you can see the chat box, guys. So click this link and join now. So upskill yourself, and don't miss this opportunity, guys. Okay. So next we will get into the topic. So these are the 4 registers. We have it in the system tick registers. Okay, system timer registers. Okay. So the first is control register, and we have a value register, we have a reload register, and we have a calibration register. So first, what we are going to do is these 3 registers. We will see these 3 registers first. Okay. So first is reload register. So this in this register only you are going to load the value of what is the value starting value, initial value. For us in our scenario, it is going to be 15, right? Because it is going to count from 15 to 0 down count. So we are going to load the 16 minus 1 in this load register only. So what is the maximum value for this load register? It is 16 777 215. So this is the maximum value. So it is max sum of the 24 bits. So the counter counts the downwards from reload value to, which is the reload maximum value we are given, to the 0. When this when writing the reload to the 0, this is a system clock and independently of the system ticking. System tick means it is interrupt. So to calculate the tick, calculate the time interval between the 2 ticks, you can use this formula. So reload plus 1, which is 15 plus 1 will be 16. So into source of clock period, it is clock frequency. You can use the clock frequency to measure the interval. Okay. So next is value register. So this is a register. We have to say to where. So as I said, so tick is going to, when it is reaches a 0, it is going to give an interrupt, right? Interrupt, or it is going to do some operation. So it is going to interrupt. It is going to give an interrupt, as well as it is going to give an a flag. So I can set a value. So I'm going to set a value in our scenario. I'm going to set a value 0 because it is counting from 15 to 0. Instead of 0, I want to generate an interrupt at the third 3. So then I can give the value as 3. Then when this it starts from 6, not 6, it starts from 15, and when it reaches 3, it will give interrupt. This is how the system value is register is used for. Okay. Next is how to calculate the reload value. So consider we are using suppose we are using a clock frequency of 80 megahertz. Okay. So my system tick interval is I need is 10 microseconds. So what is my reload value? I want to calculate. So for this purpose, what is the formula? So I need is 10 microseconds. So 10 microseconds into what is our frequency in our scenario? It is 16 megahertz. So 16 megahertz. So we will get the value of. So what is the value you will get it? You will get the value of 16 minus 1. So which is 15. Okay. So this is how we will calculate the reload value. Okay. So next we will develop the code. Okay. So now we will get into code. Okay. We will develop the code. So first I will get the okay. So first I have to start the new project. So now we have to go to the board. Next give the core and go to the device and give the startup. Now we will add the .c file. Okay. So first thing you have to do is include the startup file. So what is the first thing we have to do? We will get into the control registers. Okay, we will get into the registers. Okay. So the registers will be available in the programming manual. So you have to check the. You should not go to the referral manual. You have to check the programming manual. So in this, you can see we have a core peripheral. In this, you will have a dedicated system timers. So in this, we have 4 registers. One is control register. In this, or 31 to 17 bit is reserved, and 15 to 3rd bit is reserved. So 16 bit is count flag. So which is, I will show it right. So you can see we have a count flag. So this is a 16th bit, this is a control register. So we have a 0th bit as an enable bit, first bit as an interrupt enable, and second bit as a clock source function. Okay. So we will. So you can see. So you can see we have 16 bit as an count flag and second bit as a clock source. So we can use this edge clock, or you can use the system clock. Okay. Then we have a system tick exception request enable. So by enabling this, the counting down to 0 to accept the system tick exception request. So this is going to give us a logic onto the AND gate. Okay. So next is 0 bit as a control enable bit. Okay. So next register is load register. So here we are going to load the values in the 0 to 23 bits. So this is a register where you are going to give the value. Okay. So to where from start. Then in this register, in the current value register, you are going to say at which place, at the which value we have to generate an interrupt or a count flag. Okay. So we will set those value in this value register. So next is calibration register. We will we will not use this. So we will see this later. This is a 10. Before that, we will see this. Okay. So 10 ms means it is it is 10 microseconds. So it is for the use of the taking the time. So reading the time. Okay. So it is we will have a calibration. So we will not going to use this function. We will see it later. So now we have seen the registers. Now we will get into the code. Okay. So what is the first thing we are going to create is we will create a delay. So delay of milliseconds. Okay. So this is a delay for milliseconds. And we are going to create a void of it is for microseconds. Okay. So first we will create this function. So first is we are going to create this microseconds. Okay. So we will copy this. So what is the first thing we have to do? We have to say the we have to load the load register. So you have to give the reload value. Okay. So what is the reload value? So I'm going to use this. I'm going to use so you can see we have a calculator here. So my frequency is 16 megahertz. So 16 into the power of 6. So I'm going to use I want this 1 megahertz of frequency, which means it is going to be 1 microsecond. So the reload value from the time range is from reload value to 0. It is going to be the time proportional to 1 microsecond. Okay. So I will do this. So we will get the value of 16. Okay. So we will so we have to load in this reload value register. Okay. So go on system tick. In system tick, we have a load register. Okay. So what is the value? So 16 minus 1, it is 15. Okay. So it is going to count from 15 to 0. So it is what is the time range from 15 to 0? It is going to be 1 microseconds. Okay. So next is we have to give the set the value at which place we have to create a interrupt or count flag. Okay, so turn value register. So we are going to generate a count flag or a interrupt in this 0th position. Okay, so next is we are going to we have to enable the counter and we are going to enable the source. Okay, so in control register we will enable the counter first. So it will be in the 0th position. Okay, so next is we are going to use the processor clock itself. Okay, so you can see we are going to use the processor clock. What is the processor clock is? Our processor clock is 16 megahertz. So it is a system clock. Okay, so I'm going to send the logic one here. Okay, it is in the second bit, right? It is in the second bit. So now we have enabled the clock source. Now what is the where is the value is going to set is? Now I'm going to create a for of. So now I'm going to check this flag. So when this flag is going to set is, so when this flag is going to set is when the from the reload value, what is our reload value? It is 15. When it comes from 15, when it down comes from 15 to 0, when it reaches 0, it is going to set our count flag to the logic 1. So we are going to get a flag like 1. Okay, so we are going to read it. So what is the time frame for from 15 to 0? That is 1 microsecond. So every 1 microsecond it is going to create a tick function. So we mentioned in lesson a tick function. Okay. So it is going to create a tick function. So we have to check it. So we will check whether we are getting it. Okay. It is in the control register. Okay. Check it with 16th bit. So we are going to wait till this bit is get set. Okay. So what is this loop is going to do is now. So every count flag is going to set at the time frame of every 1 microsecond. So if I have to calculate 10 microseconds. So I have to give a delay of 10 microseconds. Then what is the value I have to give? I have to give 10 microseconds here. Then it gets settled in this loop. So it will run from it will run from it starts from 0 and check whether the system tick is count flag is 1. So it is 1 means it is now the 1 microsecond is completed. Then again it gets to the loop. Then again it will check with this when whether this second microsecond is finished. Like that it is going to check till the value I have given. It is 10 means it's going to check till the 10 values. Okay. So 10 times it is going to count flag is going to set. It is going to become 0. Then it is going to set. So it is going to be repeatedly it is going to happen. Okay. So then we will we will disable the timer. We will disable everything. Okay. Now we have created the delay function for microseconds. Now we will create it for the function for so next we will create a function for milliseconds. Okay, so same this, copy this. So you can see, I will explain it. So what we are going to do is, now we have loaded the value 15. Then when we have to create an interrupt, it is at the value 0. Then we have enabled the counter and we have used the processor clock, which is a main clock. CPU clock is 16 MHz. So now I have given the, so I will explain this. So I have given the 10 microseconds here. I have given the value 10. So this 10 will get set here. So when this count flag will get the logic 1, when this the value from 15 to 0. When the value down counts from 15 to when it reaches 0, it is going to create a interrupt as well as count flag as logic 1. Okay. So what is the time period for 15 to 0? It is going to be 1 microseconds. So for every 1 microsecond, it is going to create a count flag 1 for me. So now it is in this for loop, we are going to give the 10 here. So it is going to check it first loop, so it is going to get 1 microseconds. So till getting 10 microseconds, it is going to get in this for loop. Okay, so next we will disable this counter, processor, clock, everything. Okay, so now this is for microseconds. Now we will create for milliseconds. The simple step is same step. So what we have to do is, so 1000 microseconds is equal to 1 milliseconds. So 1000 milliseconds is equal to 1 second. So we have to multiply it with 1000. So this will create a delay in milliseconds, right? So now we have created the milliseconds delay. Then now we will create a GPA function. Okay, void of GPA void. So what is the GPA function will be? I'm going to use the port D. So which is I have an inbuilt LED in the pins of 12, 13, 14 and 15 in port D. Okay, so I'm going to use this. So first we have to enable the clock. It will be port D will be in the third position. Then we have to set the motor. So I'm going to use this pins as a general output. So port D. Motor. So what I have to send this? I have to send the logic onto the 24th bit. So I am setting as a general output. Okay. General purpose output. When 26. Then 8. So this 28. So you can refer the reference manual. Okay guys. So for this questions. Okay. So I will make it quicker. So this I have already teach. So I have gone quickly. So we will make this we'll define this function here. So next thing we have to do is we have to create the int main function. Okay. So go to the int main of void. So I'm going to initialize the GPIO first. I'll call this GPIO function first. Then I'll create a while. So we have a BSR register. So in BSR GPIO of D. So in BSR register, I will first tune on these LEDs. Okay. So on left shift off, say 12, 13. So we are going to configure use these pins only. So 12, 13 and 14 and 15. Okay. So now we have tuned on the LED. Okay. Then what we have to do? We have to create a delay. So I will create a delay. So delay of, I'll create a millisecond delay. Okay. So I'm going to create a delay for 1 second. So my LED is going to tune on for 1 second. And now I have to tune off the LED, right? So for that we have to reset the LED. So we have to send logic 1 to the corresponding registers in PSR. So you can refer to the reference manual, which I have already sent. Okay. So it is going to be bit is 28. The corresponding bit is 28 on left shift of 29 on left shift of that. So now we have, now then again we will create a delay. So it will be 2000 2 seconds. Okay. So 2000 milliseconds is equal to 2 seconds. So now we have completed the code. Okay. So we will compare this. We have one error. So where is this error? So we have mentioned in this. We'll do this. Okay. So now we will compile this. So we have 0 errors. Now we will. So before uploading the code, we have to select the output debugger. So go to the. I'm using this ST-link debugger. So sorry, I have forgot to plug the. So we have TOK 1450. So we have given this as 31. It is not 31. It is 30. Okay. So now we will compile this. And I will upload this code. Okay. So now we will. Now the code has been uploaded in the discovery board. Okay, now we will see the output. Okay. So you can see the LED is tuned on for 1 second and tuned off for 2 seconds. So this is how we will create a delay using a system clock. Okay, system timer. So next session we will focus on creating a interrupt. So we are going to get into the interrupt concepts. Okay. So guys, stay tuned and thank you for session. Okay. So today's session is over.